Hello everyone. So first we're going to start off at looking at reaction rates. So we've got reactions happening all the time, all around us. Some of them are really slow. So slow ones are things like if I can use this thing. I'm sorry. There you go. An iron nail. So an iron nail will slowly be breaking from its reactants, which is our metal, which is iron, and then into our oxygen with oxygen and water, and it's becoming iron oxide. So it's getting that rust, and it's a slow process generally, not super fast. Then we have really fast reactions. So fast reactions will be something like combustion. Combustion will be happening pretty quickly. So, oh, that's very safe. Right, so combustion. I didn't have to wait ages for that to burn. It happened pretty quickly. So those are our reaction rates. When we talk about the rate, we're talking about how fast something happens. So we will talk about time. It's about this happens in this time, generally seconds or minutes. We're not really looking at things in hours, but there might be some examples. So I would be watching my units. So we're looking at rate, and we're looking at how we go from one side of our equation to the other. We're going to push it one way, and then we're going to push it the other when we look at equilibrium. But at the moment we're just going very simply. We've got our graph, and we've got something, we've got our equation, we've got our reactants over here, we've got our products. How quickly do we go from this side to this side? So we can measure two different ways of doing this. Really, ideally, we might want to do both to show ourselves we know what's happening, or we might just do one. So very simple, we could do this ourselves. Effervescent aspirins. Ooh, lovely, great and fun. Water. Oh, I shouldn't probably be showing you in a beer glass, but so water in a beer glass. So the two ways we can measure the breakdown of the tablet, so the aspirin. Probably easier would be to measure the gas being given off. So the amount of, I think it's carbon dioxide being given off. We could have a sealed container, could measure how much is in there, and have a tube coming off. Very simple kind of chemistry. So we're going to be looking at how we measure what's coming out by our rate of reaction. And most of our reactions are going to be pretty quick. We're not going to be looking at really slow ones, because we kind of aren't going to be using those in an industrial way. So rates of reaction. Rate is how quickly something happens. So the rate of how quickly you move out of the sofa to go and do some work, that's a rate. Right. First point.